Here we have the QPSK model. QPSK stands for quadrature phase shift keying. In QPSK, data groups are divided into groups of 2 bits, and each group of bits is represented by a specific value of amplitude, frequency or phase in the phase of the carrier. Quadrature phase shift keying. Quadrature phase shift system has 2 successive bits in a bit stream and combined together to form a message, and each message is represented by a distinct value of phase shift of the carrier. Here we have the QPSK modem. It consists of clock, the even and odd clock generator, pattern generator, odd and even data generator, sine and cosine carrier generator, the BPSK generator and the QPSK generator. The second part consists of the carrier recovery section, and the last part is the receiver section. For every pattern or the wave, we will be checking the amplitude and bit duration. Now we will check the clock, odd clock and even clock. Now here we can see the clock, the odd clock and even clock. Here we can notice that the time duration for even and odd clock is double than that of the clock. In the next step, we will be checking the pattern, odd pattern and even pattern. Here we have the data pattern generated, the odd data, the even data. The pattern we have 1 0 1 0 0. Accordingly, the odd data generated and the even data generated. Now after checking the clock and the pattern generator output, now we'll check the sine carrier and cosine carrier. Here we have the sine and cosine waves respectively, measured frequency and amplitude. Now we'll give the odd and even data generated to the input of the multipliers and check the output BPSK1 and BPSK2. Here we have the odd data, BPSK1, even data and BPSK2. Here we can see the phase shifts where the bit is changing from 0 to 1, and from 1 to 0 we have the phase shift. Now we'll check the QPSK at the output of the adder. Here we have the BPSK1 signal, BPSK2 signal, the addition of both the signals as QPSK. Notice the phase changes. Now we'll see the carrier recovery section. Give the QPSK output to the input of the squaring circuit, the output of squaring circuit 1 to the input of squaring circuit 2, output of squaring circuit 2 to the bandpass filter, output of filter to divide by 4 network, and check the carrier. Here we can see the sine carrier and the cosine carrier. Now we'll see the receiver section. Give the recovered sine to the multiplier 1, recovered cosine to multiplier 2, give QPSK output as the input to the receiver. Check the output. Here we have the received data pattern 1 0 1 0 0.